Welcome to Cooking with Starlight. If you're going to mess around with solar cookers, please wear sunglasses. In another video I talked about insulation, which is one of the 3 elements that you build into a solar cooker. The insulation is to stop heat escaping once your black target starts to heat up. You may remember this heat trap here, big glass heat trap. Today I want to compare this heat trap with a plastic oven bag heat trap. These are the sorts of oven bags that you can get to put in your microwave to cook vegetables and so on. You can see that this is a very light plastic, and that's one of its advantages. You could take it anywhere with you, but they don't last very long because they get dirty and they're a pain to actually put on. You have to blow them up and then clip them to stop the air escaping, because you don't want them to come into contact with the black target. Glass ones, of course, are very heavy. You wouldn't want to carry it anywhere with you. Certainly you can't backpack with one of those. But they're very easy to keep clean. They're very easy to use. You just put the stuff in, put the lid on, and you're away. They're more expensive. These cost about, I don't know, 20 or 25 pounds, but unless you drop it, it'll last forever. These, on the other hand, are very cheap, but you have to replace them. They both do similar jobs. They both provide an air jacket around the black target pot and prevent too much heat from escaping. But there's another thing that you might not know about them. So I'm going to take you forward to the cool of the evening for a little experiment. Hello, it's evening now and much cooler. So here we are to do our experiment. We've got a thermal imager. This is a refuse sack, and I've stretched some of this plastic over this frame here. We've also got one of these oven bags that I showed you before. We've got a recently boiled kettle and a cup, and one of these heavyweight glass heat traps that I showed you before. So I'm going to use the thermal imager to show you what happens when we put some hot water into this mug. Okay, I'm just going to pour some hot water into this mug. About halfway, 2/3 of the way up. And you can see immediately that the hot water is heating the mug, and the outside of the mug is becoming hotter, which you can clearly see. And now I'm going to lower the mug into the heat trap. And what you should see is that the mug disappears. In other words, the thermal imager can no longer see the heat given out by the mug once it's below the level of the heat trap. And now I'm going to lower the mug behind this bit of black plastic. And you should be able to see the mug quite clearly through the plastic from the image on the thermal imager. The thermal imager can still see the mug through the black plastic, whereas using the conventional camera that you're looking through, it's obscured, it's behind the black plastic, so you can't see it. So radiant long-wave infrared radiation travels straight through this plastic. And now I'm going to put the mug behind this oven bag, which you saw before, and see if we can see through that with the thermal imager. And as you should be able to see, the thermal imager can quite easily see straight through 4 layers of this oven bag. And of course you can see it as well through the conventional visual part of the spectrum camera that you're looking through now. But here's the point: this long wave radiation, the radiant heat from this mug is just going straight out through the plastic as detected by the thermal imager. Welcome back. I hope you were impressed with the experiment. What we learnt was that most plastics allow radiant heat to escape very easily. So unless you have polycarbonate heat traps, which do work, try and avoid plastic. So glass if you can, plastic if you must. One of the big, hello luxury cat, what do you want? Why don't you go away?